Alright, today's video is about scientific notation and writing numbers in scientific notation and standard form. So our objective is students will be able to convert between scientific and standard notation. Convert between scientific and standard notation. So the first thing that we're going to do is talk about what scientific notation is. And in order to do that, we're going to talk about the idea of powers of 10. When we use scientific notation, we use a base of 10, or we use the number 10, because 10 is something that also helps us represent place value. So the first thing that I want you to do is go ahead and pause the video, and I want you to figure out what are all of these different exponents going to equal. 10 to the fourth, 10 to the third. So go ahead and pause the video. When you're ready, press play, and you can see the answer. Okay, so double check that you have the exponents evaluated correctly. Now let's talk about what we're noticing. First of all, you should notice that every time we go down one exponent, we're actually dividing by 10. So 10,000 divided by 1,000, that's 1,000. 1,000 divided by 100, that's 100. What's also interesting is you'll notice that we're decreasing by a 0. And that's why when we do scientific notation, we use the base of 10, because it allows us to do place value. Remember that when we think down here, this 10 to the first power is 10, but 10 to the negative first is 1/10. 10 to the second power is 100, but 10 to the negative second power is 1/100th. So it's a really great way for us to see how things move across different place values by using a base 10. Alright, so let's kind of get the basics of scientific notation. So I want you to find a blank spot on your notes. We're going to take a little bit of notes. You should have some space underneath the table and above the next section of notes that starts. So what is scientific notation? So what is scientific notation? Scientific notation is always going to be written like this. We're going to have a number. It's just one number to the left of the decimal. One number to the left of the decimal. So after this number, there's going to be a decimal point. We're going to have one number to the left of the decimal. Then to the right of the number, we can have as many other numbers as we want. So this is going to be a number, this is going to be a number, this is going to be a number. Any of these, we can have as many as you want. So as many to the right as needed. As many to the right as needed. Okay? Then, after we have a number, a decimal point, and then maybe a few other numbers, we're going to have times 10 to the, remember we have a base of 10, some power. So this is our base. It must have a base of 10. You must have a base of 10. And then this right here, that's going to be the power. Okay? It could be a negative or a positive power. We don't know. It just depends on the example. But you must have one number to the left of the decimal, a multiplication sign, a base of 10, and then some sort of power. And this can be a number, negative or positive. So, for an example, okay, here's an example for you. You could have 1.03 times, now I'm using an X, but we could also use a dot, so let's put a dot, 10 to the third. So does this fill in the requirements? One number to the left? Yes. Some numbers to the right? Yes. A multiplication sign, a base of 10, and a power. You might have 3.657 times 10 to the negative third. One number to the left, some numbers to the right, a multiplication sign, a base of 10, and an exponent. Okay, these are both examples. Let's talk about some non-examples. Let's talk about some non-examples. And as I show you these, I want you to kind of look at it and say, okay, why is this a non-example? What is wrong with this example? Why does it not work? All right, here is your first non-example. Let's say I gave you 25 times 10 to the third. Well, the first thing I see that's wrong is that we have a 25 here. And scientific notation has to have one number, then a decimal point, and then some other numbers. This is missing a decimal point. So this is missing a decimal. Okay, that's a non-example. We're having some trouble with the board for some reason. We are missing a decimal. So this example does not work. Let's do another example. What if I had a 36.02 times 10 to the negative third? Well, I have a decimal, I have a multiplication, I have a base of 10 and an exponent. Here, my decimal is actually in the wrong spot. You can only have one number to the left of your decimal. If you have more than one, it is incorrect. So this is two numbers to the left of the decimal. So that is incorrect as well. Let's do one more example. I give you 2.6 times, and I'm using the x as times now, but we've been using dots. Just remember that these all mean times. 2.6 times 100 to the negative fourth. Right? Well, let's check our decimal. I have one number to the left, 2, that's good. Some numbers afterwards, yes, a multiplication. 100 to the negative fourth. I'm looking back at my notes, and I must have a base of 10 in order for it to be in scientific notation. So this is wrong because it has no base of 10. We need a base of 10. Right? So those are all non-examples. We'll talk later about how to change these non-examples into scientific notation. But for right now, I want you to just see what is scientific notation, what does it look like. All right, so let's go ahead and do some examples. Okay, before we start, I want you to write a couple of notes for yourself and how we're going to do scientific notation. Okay, so I'm just going to write those notes down here because I'm going to have a little bit of extra space down here. Put a box. I'm going to put my notes right here. Okay, the first thing that you're going to want to do is you're going to, number 1, place new decimal. The first thing you're going to do is to place your new decimal. And actually, so we don't run out of room, I'm going to write this a little bit bigger, and then I'll erase it at the end. So please make sure that you copy this down. First thing, we want to place new decimal. Place your new decimal. Place your new decimal. The second thing you want to do is you want to determine whether you're going to use a negative or a positive exponent. So positive or negative exponent. Which one is it going to be? So just so that you have an idea, a positive exponent. A positive exponent is for big numbers, or when you move to the right. A negative number is for numbers that are smaller. They're going to be between 0 and 1. For numbers between 0 and 1, or when you move to the left. After we determine what it is, we're going to underline and count digits. And I'll go through all of these different steps with you. Underline and count digits. Okay, so let's do some examples so that you can see. Here's our first example. So let's say I had 34 million. 34 million. Right now, 34 million is in standard form. Standard form just means the number, okay? The number itself, standard form. And I want you to put it into scientific notation. Remember, scientific notation is going to be a number, a decimal point, some numbers, times 10 to some sort of power. So the first thing we want to do is place our new decimal. Your new decimal needs to be placed right after your first number. So I want you to start at the left, and I want you to go over until you find the first number. The first number is 3. We're going to place our decimal right in between 3 and 4. So the first thing we're going to do is place our new decimal. So our number is going to be 3.4. As soon as you hit zeros, and after those zeros there's no more numbers, you're not going to list the zeros. You're just going to put 3.4. Okay? So we're going to use a multiplication symbol. Next, we need to determine whether we're going to use a positive exponent or a negative exponent. Is this going to be 10 to the positive number or 10 to the negative number? This is a big number, right? This is not a number between 0 and 1. This is a big number. We're going to use a positive exponent. You also can tell because if we were to count to the end of our number this way, we're going to the right. So remember, if it's a positive number, you're going to the right. We're trying to get to where our other decimal place is, okay? We're trying to figure out the number of spaces between two decimal points. Here's our first decimal point that we just placed, and our other one would be here because after this, this is where the number ends. So I know we're going to use a positive power here. Next, we want to underline and count the digits, and let's add to our steps. Underline and count the digits between decimals. Between decimals. Okay? And you might have to put your first one in, and you might also have to put in your second one because it's assumed that that other decimal is right before you get to things that are lower than 0. So I'm going to underline the spaces in between. 1, 2, 3, 4, 5, 6, 7. There are 7 numbers in between these two decimals, so this is 3.2 times 10 to the 7th. Okay, let's go ahead and do another example. Let's say you have the number 7,506,000,000. The first thing we're going to do is place a new decimal. So we're going to start on the left, and I'm going to look for the first number. I'm going to put my decimal right there. I need to also place my second decimal. So I'm going to place my second decimal where the number ends. I need to determine is this going to be a positive or a negative number. Well, from decimal to decimal, I'm moving to the right. Also, this is a really big number, so I know it's going to be a positive exponent. And I'm going to count the number of spaces. So I know it's going to start out at 7.5. Now, a common mistake that a lot of students make is that they stop right here. You need to go until you reach your last number that's not a 0. So that's a key point that we're going to write in here. Key point. Go until last number that is not a 0. You want to go until the last number that's not a 0. So 7.5. I'm going to include this 0 because that's still part of it. 6. After this 6, all I have is 0, so I can stop. So times 10 to the, and let's go ahead and count the number of spaces in between our decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th. Alright, we're going to do 2 more examples. Let's take an example like this. 0.0000, 5 zeros, 802. Okay. The first thing I want to do is figure out where my decimal goes. So I'm going to move this way until I come across my first number that's not a 0, which is right here. Here's my new decimal point. So it's going to be 8 point, and remember we want to go until we reach the last number that's not a 0, 0, 2, times, now let's see, are we going to use a negative exponent or a positive exponent? Well, a negative exponent is for numbers between 0 and 1. Is this number between 0 and 1? Yes, it is. This is a number between 0 and 1. So we're going to use a negative exponent. Also, if we count, we're going to start at where our decimal was, and we're going to end up counting this way to get to our other decimal. We're moving to the left. So that's another way to see that, oh, this is going to be a negative exponent. So I'm going to count 1, 2, 3, 4, 5, 6. So this is going to be a negative exponent, so it's 10 to the negative 6. Okay, one last example. Let's take 0.020000005. Let's change that into from standard to scientific. First thing I want to do is place my new decimal. So here's where my first decimal was. I'm going to go until I see a number. I'm going to go 1 after that and place my decimal point. Okay, now I have my decimal point placed. I know it's going to be 2 point. And remember, you need to continue until you get to the next number, or if it's all zeros, then you can just leave it. 0.00005. It's going to have to be 0.200005 times 10 to the, is this going to be a negative or a positive exponent? Well, I know my number is less than 1, so it's going to be a negative exponent. Also, when I count, I'm going to count from the decimal I placed. I'm going to end up counting to the left, so that also shows me it's negative. How many spots are in between these two decimal points? 1, 2. So 10 to the negative 2. Okay, what I want you to do right now is do some practice. This is a few pages ahead, so flip to you see this practice. Go ahead and pause the video, try this practice, and then press play to see the answer. Alright, so I showed you the answers to 2, 4, 5, and 6. Go ahead and check those. And then I want to talk really quickly about 1 and 3 and how we would do those. We're going to talk about questions 1 and 3 in a little bit when we talk about tricky problems. So I'm going to have you come back and revisit these. Don't worry about doing 1 and 3 right now. Just check that you got these other 4 correct. Okay, so let's talk about going from scientific notation to standard form. How do you go from scientific notation to standard form? All right, so we are going to use the same idea except slightly different. So let's say we had an example like this. Example number 1. Let's say we had 7.506 times 10 to the 9th. 7.506 times 10 to the 9th. Well, the first thing that we want to do is we want to go ahead and take our number and write out the number we're given. 7.506. Now, I know that it's going to be a big number. It's a positive exponent, so I'm going to want to go this way. And I'm going to start at my decimal, and I'm going to count out 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that I moved 9 from this decimal 9 places to the right. Any place that does not have a number, we're going to fill in with zeros. Now right now, this looks kind of sloppy. We have lines, we have decimals, so we need to clean this up a little bit. This decimal was only there for the purpose of our place value, so when we rewrite this, we're going to rewrite it without this decimal. So that's going to look like 7506. 1, 2, 3, 4, 5, 6 decimals. The last thing that we should do is start at the right-hand side, and we should put in our commas. So every 3 numbers, we need a comma starting on the right-hand side. So this is that first example we just did, but now we went from scientific to standard. So 7,506,000,000. Alright, let's go ahead and do another example. Let's say you had 3.312 times 10 to the negative second. And you'll notice I'm using either a dot or an X, but they both mean times. So first thing we want to do is write out the number 3.312. Now this is a negative exponent, so I know my number is going to be less than 1 and greater than 0. And since it's negative, I also know I'm going to move to the left. So I'm going to need to count out 2 spots to the left of my decimal. 1, 2. Now, this is a number less than 0, so our new decimal is going to go right here. Any number that doesn't have anything underneath in it is going to be a 0. So let's go ahead and simplify this. 0.03. This is our decimal from here, so it's gone. 3, 1, 2. Now, does this need commas? No, this is a decimal, so it's not bigger than 1, so it does not need commas. Let's do another example. What if we had 8 times 10 to the first? 8 times 10 to the first. Alright, well, this is another decimal. And you might think, well, this isn't scientific notation, but there is a decimal right here, right? And there's no numbers to the right, but there might just be zeros. So we're going to write out our 8. I'm going to put in our imaginary decimal. And we know we need to go 1 to the right because it's a positive 1. So I'm going to go 1 to the right of the decimal. Fill that in with a 0. Let's clean this up a little bit. We have 8. This decimal is what we had to add in normally, so we're going to drop it. 0. 80. Let's do about 3 more examples. What if I gave you 5.32 times 10 to the 0 power? 5.32 times 10 to the 0 power. So I'm going to take this, I'm going to write it out. 5.32. Now, it's to the 0 power. That means that we didn't move any to the left, and we didn't move any to the right. Well, we have 10 to the 0, and 10 to the 0 is just 1, right? We know that this is 1. And so this is really just like 5.32 times 1, which just is 5.32. So 10 to the 0, anything 10 to the 0 is just going to be that number itself. Let's do 2 more examples. We have 7.312 times 10 to the third. So I'm going to rewrite my number, 7.312. I know I'm going to have to move to the right because it's a positive exponent. So I'm going to count 1, 2, 3 spaces. Now I happen to run out. I don't have any extras to fill into 0, but that's okay. So that just means that this number was 7.312. I'm going to put in my comma. Last example. Say you had 3.602 times 10 to the negative third. Right, so I'm going to rewrite my number, 3.602. It's a negative exponent, so I know I want to move to the left, and I'm going to count out 3 spaces. 1, 2, 3. It's a negative, so I'm going to have to put in my new decimal, fill these in with zeros. So it's going to look like 0.003602. 0.00